Hello, my name is Howard Chorney, and I'm a member of the Shunra Professional Services Engineering team. Today I'd like to talk to you about possible solutions to problems that we've discussed during our last two modules. Module 1 being the Shunra Basic Engineering Network class, Module 2 being the Shunra Performance Engineering Applications class. So, as you may recall, we discussed these things in detail and we came up with lots of problems. Today what we'd like to look at are solutions from a network engineer's perspective and from an application development engineer's perspective. First, I'd like to discuss some possible solutions from the networking side. Well, as you see here, we have a couple of different options that we'd like to present to you. Option A being proactive, which I'll be discussing with you in a few minutes, and then option B, where you can just troubleshoot the problem like our friend here on the screen, who just happens to be dealing with an end user and trying to understand if that user should type a lowercase 0 or an uppercase 0. But enough of that, let's go to the real piece. You'll notice the first bullet says test, test, test. And we completely advocate that all the time. You gotta test, you gotta test, you gotta test, or else you'll never know that you're gonna prove your solution or if your solution works. But now let's move on to something else. So first thing I'd like to do is talk about network optimization. The first thing that we can do as a network engineer is capacity planning. We really need to understand what we're going to be putting through the network and understand the utilization before we can really design or troubleshoot that network. Second thing are kind of similar, being QoS and MPLS. QoS stands for quality of service. With QoS, what happens is we'll actually sit there and prioritize the different types of traffic going through the network. And actually, I have a pretty interesting illustration I can do here. So if we recall back to the first module, our Basic Engineering Principles module, I drew the highway. And we'll make believe we have a bunch of cars on the highway. And let's make believe we're going through a toll booth. Now, I know many of you may not know what toll booths are, but me being a native New Englander, I've lived with toll booths all my life. So what happens when you're on a highway and go through a toll booth is you obviously have to pay some sort of coin or dollars, or in some cases multiple dollars, to continue to drive on the highway. And when you do this, you go through toll booths. And basically there are three different ways you can pay in a toll booth. And this is how I like to equate this to QoS. The way you pay basically prioritizes how you get to go through the toll booth. So if we were to deal with a toll taker, this is usually the longest line at a toll booth. Why? Because you have to have a cash transaction with the toll taker. Consider this kind of data traffic. So it's got the lowest priority, and data usually has the lowest priority in QoS. And so this traffic will basically queue up. Then you have your coin traffic, or I'll call exact change. You still have to physically stop, throw the exact change in, and drive through. However, there's not as much time dealing with a human being here, so it's basically an easier way to flow through the toll booth. So if you have exact change, you actually are going through at a higher priority. Now, using the toll booth analogy still, let's talk about VoIP traffic. Now, throughout the country, a lot of these transponders have been put into play. It's called fast lane, easy pass, whatever you want to call it. And basically what happens is this, using a little tag on your car allows you just to drive right through the toll booth. So again, being a higher priority, this lets you through. So this is kind of how QoS works. Prioritizes the different types of traffic to allow that traffic to flow through the routers more efficiently and quicker. Now let's talk about application acceleration. First thing I'd like to do is talk about WAN acceleration. WAN acceleration helps move traffic rapidly from point A to point B in a wide area network. WAN acceleration works on three principles. So let me do a quick illustration for you here. So basically we'll say we have a remote office with a gaggle of clients, and we're all going to be hitting a data center. And there's going to be lots of different types of traffic going from our clients to our data center. So basically what we're going to do here, these nodes would go through our routers, into our wherever DMZ firewall, but there we'd also go through something called a WAN accelerator. There are several different vendors of WAN accelerators, and we're not going to advocate one vendor over another. They all work a little differently. They all work a little differently on specific types of traffic. But basically a WAN accelerator is a large compression and caching box. It also does protocol conversion. So when you deploy a WAN accelerator, the first thing that's going to happen is you're going to start realizing content compression. So when I send data from our remote site here to our data center here, the first thing that's going to happen is it's automatically going to compress part of that data. Okay, so compression would be one piece. Another big thing that happens in a WAN accelerator is it actually converts traffic from TCP to UDP and then back to TCP. So what's happening is all your handshaking and acknowledgments are happening between your remote site and your WAN accelerator and your data center and your WAN accelerator. So after it does all the TCP acknowledgments here, it's actually sending the traffic back and forth via UDP. And what's the advantage of using UDP over TCP? Once you send the traffic, basically the traffic's gone and you don't have any acknowledgments anymore. So there's a lot more speed going over the wire because all your handshaking and hacking is happening between here and here. The third piece, and I think the biggest and most important piece, is caching. Now there are three types of cache passes that we use with the WAN accelerator. Usually the first pass is when I send data from point A to point B or from our remote site to our server site. So WAN accelerators on both sides are actually looking for the data to cache. And they use algorithms. Each one uses a different algorithm. And actually they cache this data in memory and disk. These WAN accelerators are usually large memory and disk machines. So going back, we've just passed data over. Now he's going to learn what to cache. And that's called a cold cache pass. Nothing is in the accelerator yet, and we're just passing data over the wire for the first time. So that first pass of data, my WAN accelerators have learned what it can cache. That second pass, which is immediate, is called the warm cache pass. In that warm cache pass, in my experience, we've gotten our biggest gain in speed, okay? Because usually it learns the first time, caches it, and then transaction response time increases tenfold in a lot of cases. The last pass is called a hot cache pass. Now the hot cache pass is basically incremental as traffic continues to be passed back and forth. So what happens is our WAN accelerators start to learn about other things it can cache to basically optimize how it's going to cache. And again, just to refresh, the biggest bang for the buck I've always found is between the cold cache and the warm cache. That hot cache definitely gives us incremental gains, but our biggest gain is in our warm cache pass. And that's how the basic principles of a WAN accelerator work. Another method that we can use from a network perspective is deploy Citrix machines. Now Citrix works very well, and basically what's happening when you're using Citrix is you're hosting your application on a central machine, and you don't have to worry about going into the back end all the time. Disadvantage of Citrix, in my opinion, is Citrix is very resource intensive. So if you're going to deploy Citrix, you should definitely plan on deploying more servers than you normally would. However, you do get great security gains and you do get a lot of speed gains. So there's definitely the advantage to the disadvantage. Now let's talk about content delivery clouds. So what is a delivery cloud? Akamai, they're the leaders in content delivery cloud. If you use Amazon, you're dealing with the content delivery cloud all the time. So let's explain. Amazon.com is basically located up here in Washington. I live here in Boston and I use Amazon constantly. Have any of you ever done an Amazon search for a TV or something like that, and all of a sudden it renders about 200 different choices or images for you? Now let's think about this. Latency from Mass to Seattle, I'm going to say roughly, is about 100 milliseconds round trip. Could you imagine if I had 100 images to render? If I was waiting for those images to load from Seattle, I'd probably get in my car go drive somewhere and look at TVs that way versus looking through Amazon. Amazon, realizing this, what they've done is they've deployed these things called content delivery clouds. So basically what happens is Amazon has these sites, or other companies like Amazon has these sites all over the US, depending on what region you're in. So basically when you talk to Amazon, you're talking to a front-end CDN, and that CDN is talking to Seattle in the background. So therefore, my shopping experience is much more pleasurable because it's quicker. Why? Again, because I'm accessing a CDN, just like a user in Florida may access their CDN and go back there, or the user in Texas might be accessing it, or California, so on and so forth. And that's how a CDN works. Excellent way to help from a network perspective. So to review, we've talked about some network optimization options. We've talked about some application acceleration options. And of course, you'll notice again, testing is the way to prove things. Don't deploy without testing. Now let's talk about things from a developer's point of view. And what can you do as an application developer to help mitigate some latency issues and risks? Well, again, we have option A and we have option B. And I don't know how many of you have ever dealt with folks in option B. I know I have, and definitely not a pleasurable way to do things. So again, we're going to talk about option A. Now option A, notice, starts with test, and I can't emphasize the fact enough that testing is the key to success, and that's why it's always going to be first and last on all our slides of these types. So now let's talk about how to increase effective throughput. Server configuration is definitely an excellent way to do things, but it's not going to be the silver bullet. You can only tune a server so much to optimize it for network traffic. So now let's talk about multi-threaded transactions. As you know, when you code in whatever modern language you're coding in, you can have multiple processes and pass data through with multiple threads versus serially. Well, you can do the same thing from a network perspective. So let's take a look at this for a minute. You can open up different sockets or different ports within your network environment. So if we look at TCP for a quick second, so let's say this was a stack of frames or a stack of data and we wanted to send that data to the client. Let's just say this is video for a minute, okay? And we're going over 30 milliseconds worth of latency. In a single threaded environment, what would we do? So naturally we'd start with our three-way handshake where we'd synchronize and get an acknowledgement from the host or our server. Then we'd get our ACK from our client, and then basically the request would come through to render the video. And then what would happen is he would send frames 1 through 30, because this just happens to be the way it was designed. And then before he sent 31 through 60, he would basically wait for an acknowledgement before he would send frames 31 through 60. So this is single threaded, it's very serial. And what can happen in certain instances, especially with video, and I know you've probably all noticed this in the past when watching video over the wire and streaming type video. What happens is that you could get into a situation where you've already played through your buffer and now you're buffering and waiting for more data to come through. I'm sure we've all seen that. And this usually happens when something's very single threaded. However, since we can open up multiple ports, we can multi-thread our data transmissions. So after we go through our handshake, basically if we have multiple ports open, we can have synchronous parallel transactions going on, providing us with more data, hence making our video display less choppy. So this is the way multi-threading can help us from a network perspective. I will say most people have deployed multi-threading lately, but there's still always room for improvement in this area. Now let's talk about reduced transaction size. First thing I want to do is talk about deduplication of data. I use Amazon as a great example. So basically what happens is Amazon will store your information in a database, and when you make the request, it will actually go out and populate the fields because it already has these things stored, so you don't have to spend time going back and forth supplying the same data again. Pretty simple, pretty straightforward, done all the time, works over the network as well as it does locally. The next thing is deferred loading. Now, deferred loading is a pretty interesting concept, and let's talk through deferred loading. So let's take a hypothetical situation. I'm here in my client, and I'm going to do a query to my remote database. Say my client's here in Boston. My database server is sitting in, I don't know, Philadelphia. So let's say I do a query that's going to render 1,000 results. Now let's think about this for a minute. Your typical screen, can you display 1,000 records at once or 1,000 lines at once? No, usually you can only display between 20 and 25 at once. So if I can only display 20 to 25 lines at once, and I do a query that renders 1,000 records, why should I send 1,000 records all off at once? Basically what's going to be happening is there's going to be a lot of time going from point A to point B to send all those records out. Why not just send 25 records, or maybe send 50 records in the first shot and then 25 after? So if I send 50 here, I'll have 25 sitting in the buffer, I'll have my 25 displayed. Then every time I hit a carriage return, it can bring it in from here and send me another 25. Therefore, there's very little wait time for the end user as he's going through this. So that's deferred loading. The next step is application modularization. No rocket scientry there. Any good object-oriented programming language should help you accomplish this. The next thing is content compression. Content compression has been around since the dawn of network transmissions. A lot of early programs out of there applying some sort of compression or minimizing the amount of data you're going to send over the wire, then expanding it will compress payload size, and then you can just open it up when it gets to your client. Excellent way to do that. Another thing is caching. Why send the same data over and over and over again? Think about Google or something like that. When you load the Google homepage, it will just send me that content and it will keep it up there all the time. It doesn't resend me the Google logos or labels because it just downloads it once and it will keep it there until I close the browser. So again, why send data you've already sent over once? Kind of like deduplication of data, although deduplication of data is stored in that back-end database. Same principle though, why keep sending information over when you don't have to? The final thing I'm going to talk about now is deferred execution to the back-end database. Well, you can use stored procedures. And with storage procedures, again, you don't have to keep running things over and over again. It'll be much quicker to access. Then the final thing, of course, is test, test, test. Deploy these things, test them, and you'll be on your way to improving transaction response time in your network. Thank you.